Okay, before we start, can I just get confirmation that you guys can hear me and see my screen and see me? Okay, perfect. Cool. Now, okay, so please remember, okay, Assalamu alaikum, good morning. Welcome back, guys, to grade 11 maths, science 5 teens. So in today's lesson, we'll be covering trigonometry. Okay, so if you guys do have any questions, please feel free to ask them in the chat, in the Q&A, or in the YouTube chat. For those of you that are watching on YouTube, cool. Please do remember that the document will be sent to you guys afterwards. It's uploaded to a Google Drive. The link to that Google Drive is found in the group description. Cool. Now, sorry for being late, by the way. It's just that the first lesson got delayed, and when the first lesson gets delayed, it's a ripple effect, and now everything is delayed. Okay, but nevertheless, let's continue. We'll try and work a little bit extra just to finish up. Okay, so let us start trigonometry. Okay, we're going to go through some basics and then eventually we'll get to like the hard stuff. Okay. Okay, so firstly, we're going to talk about this. Okay, let's get rid of these lines. Okay. Now, in a 90-degree triangle, at this point, we're in grade 11. So I would hope that everybody knows what is a 90-degree triangle. I would hope that everyone has worked with Pythagoras theorem before. Okay. And everyone knows what is the opposite, the hypotenuse, the adjacent. Okay. So we'll go through it, of course. But a 90-degree triangle is here. Okay. Pythag theorem basically says if I have to create another 90-degree triangle here. Okay, let's call this A, let's call this B, let's call this C. Pythag says that the side opposite the hypotenuse okay, somebody doesn't understand Pythag, tell me. The side opposite the hypotenuse, which is A, squared is equal to the sum of the other two sides squared as well. So A squared is equal to B squared plus C squared. Okay, so A squared, the side opposite, if we square the side opposite the hypotenuse, basically you can add the square of the adjacent and the opposite. So when we talk about, okay, so hypotenuse, we know opposite the 90. Always opposite the 90, that's our hypotenuse, right? What is opposite and what is adjacent? What do we refer to as opposite? What do we refer to as adjacent? So if we select this as theta, okay, we're working with angle theta over here. Okay, that's our angle theta. Now, basically, hypotenuse is always opposite the 90. The side opposite this angle, we call it the opposite. Wow. The side next to it, we call it adjacent. Okay, there are two sides next to it, but the other one will always be the hypotenuse. Okay, the side opposite theta is known as the opposite. The side next to or adjacent to the angle is called the adjacent side. Okay, so that's how we name it. Now, we have certain trigonometric ratios or cofunctions, sine, cos, and tan. So all of these specifically have to do with theta, which is here, but sine, cos, tan in general. Now let's just do it on our own and we can refer to that little box. Sine, okay, is opposite over hypotenuse. You just need to memorize this. The sine of an angle is when you take the ratio of its opposite over the hypotenuse, the length of the opposite over the hypotenuse. When you do cos, it is the adjacent over the hypotenuse. When you do tangent, toa, it is the opposite over the adjacent. Now, there's a quick way to remember this. Sine is opposite over hypotenuse. Cos is adjacent over hypotenuse. In tangent is opposite over adjacent. So, ka, toa. That's a little mnemonic thingy that you can learn to memorize it, right? And you'll never forget it till the rest of your life. So, ka, toa. which is sine is opposite over hypotenuse, cast. Cos is adjacent over hypotenuse, tan is opposite over adjacent. Okay, so that's how we create those values. So if we have to do an example, okay, with actual, let's call this Q, R, S. Let's call this guy theta. Okay, in terms of QRS, in terms of Q, R, and S, what is the value of sine theta? Someone tell me. What is the value of sine theta? Which is very noisy. In terms of Q, R, and S, what is the value of sine theta? S over Q, very correct. So we have opposite over hypotenuse, which is opposite is S, hypotenuse is Q. Let's say cos theta. What is the value of cos theta? Okay, remembering that cos theta is adjacent over hypotenuse. Sorry, so sine is opposite over hypotenuse. Cos will be adjacent over hypotenuse. So R over Q, very good. What about tangent? Tangent theta, tangent. This is opposite over adjacent. So opposite over adjacent. S over R, very good. Okay, so now we understand our trigonometric ratios in a 90-degree triangle. Okay, let's talk about on a Cartesian plane. So on a Cartesian plane, it works exactly the same. It's just that our symbols are slightly different. Okay, so Cartesian plane again is a set of axes, a y-axis, two-dimensional axis, a y-axis and an x-axis, a y-axis and an x-axis. Okay, so we generally consider theta, you'll see when we do some examples, as the angle from 0 degrees. So this is 0 degrees. Now we go up, we have 90, we have 180, and we have 270. So from 0 degrees to wherever the angle is, that's what we consider as the angle. So in this case, this is theta. Okay. Now, theta, its opposite is always a y value. Why is it a y value? Why is it a y value? Because basically, just say my length here is 5, or my coordinate here is 5. If my coordinate here is 5, that means at this, remember, I don't think we did functions yet, but horizontal line, all horizontal lines maintain the same y value. Okay, maintain the same y value. So therefore, this coordinate here has a y value of 5 as well. Okay, and therefore the length of it is also 5 because it goes 5 units up, and if it's in line with that, we know for a fact that it's 5 units up. Thereafter, let us discuss the x term, which is the adjacent to theta. The adjacent is always an x term because, again, so this line is on the x-axis. So if we want to measure its distance, we go from there to there. So whatever the coordinate is here, maybe it's 7. Okay, it's going to be the same coordinate here because on a vertical line, x coordinates remain constant. Y coordinates change, x coordinates remain constant. So if it's 7 here, it's 7 there as well. So therefore, that coordinate is 7 and 5, and this distance of x is 7. Okay, so how we can remember it, and then our hypotenuse is our r, okay, which is the diagonal line. So sine theta, y over r, cos theta, x over r, tan theta, y over x. You don't have to learn these symbols, right? You can just use your understanding of how the 90-degree triangle works. Okay, you don't have to use those specific symbols. You can revert back to just using opposite over hypotenuse, adjacent. Some people prefer this, but yeah, if you do, by all means use it. If you don't, just use opposite adjacent hypotenuse. That's it. Okay, basic cast diagram. So we have to understand the cast diagram and exactly what it means. Okay, it shows the quadrants where each trigonometric ratio is positive. Okay, so as you can see, cast, okay, I don't know how you guys remember it. right? Some people do ASTC and they learn like an abbreviation thing. Some people do CAST. Okay, maybe it would be nice to do ASCT because it starts A in the first quadrant instead of C starting in the fourth quadrant. I know some people do all students take CAT, the subject or the drug, whichever one you prefer to remember it with. I don't know. Yeah, thank you. I was gonna say, can I please give some, whatever you use, just type it in chat, and maybe other people can benefit. All stations to keep them. Yeah, exactly. You can make up anything. Anyone else with anything else? Okay, ASTC, but yeah, it's called CAST because normally people, it's the only word you can spell. So CAST. But I would probably prefer you remember it from the first quadrant. Like start your first letter of the first quadrant. Okay, ASTC, so that's what it is. So what exactly does it mean? If we consider the first quadrant, because it's A, it actually stands for all. Okay, and it tells us that all trigonometric ratios are positive in that quadrant. Okay, all of them. Then if we look at S, second one, sine, it tells us that only sine is positive. Now, since only sine is positive, that means that cos is negative and tan is negative in that second quadrant. Then we look at the third one, it tells us that tangent is positive. Since tangent is positive, that means that sine is negative and cos is negative. Now, you don't have to all memorize all, of course, it's implied. When you say cos is only positive, then it obviously naturally implies that sine and tan are negative there. In this case, yep, sine and tan are negative. Okay, so that's basically CAST diagram. When we do reduction now, you'll understand what that means. Like, how do we use it actually? Sorry. Before we do reductions, however, I just want to discuss reciprocals. Now, it's generally not examinable of anything past grade 10, but just in case, it's not rocket science. So just in case you need to know it, let's just go through it so that we can revise and you can remember it. So what you need to remember is that cosec, sec, and cot. Now, if you're struggling to remember which one is for which, just look at the third letter of each one each time. So in cosec, the third letter is S, which means it's for sine. In sec, the third letter is C, which means it's for cos. In cot, the third letter is T, which means it's for tangent. Okay, and it's basically the reciprocal, which basically means, that you inverse it. So instead of having, so cosec is the 1 over sine theta. Okay, now when you have 1 over sine theta, it becomes 1 over opposite over hypotenuse. And then remember, division of fractions you cannot do. You simply flip in times or flip and multiply. So you'll have 1 times h over o. So this becomes h over o, hypotenuse over opposite. And that's exactly what the reciprocal is. So cosec, instead of it being opposite over hypotenuse, like like sine, cosec is actually hypotenuse over opposite. Okay, so then when we have cos and sec, so cos, obviously, we know that cos, let's just write each one here. Sine is opposite over hypotenuse, but cosec is hypotenuse over opposite, basically, the inverse. Cos is adjacent over hypotenuse, and sec is hypotenuse over adjacent. Cot is opposite over adjacent. So cot is adjacent over opposite. Okay, inversed. Cool. And you can inverse it in terms of the Cartesian plane thing as well. There's no need for us to go through that. Okay, special angles. Right. So special angles use the special triangles. I've written the special triangles on the right. On the right, let's complete these. Okay, so special angles are important for us to know. We need to know the value without using the calculator. We need to know the unrationalized answer. So the reason I've written 0 and 90 is in it, because those are easy. Okay, you can actually use the trigonometric graphs to decide what's the value of sine 0, what's the value of sine 90, what's the value of cos 0, what's the value of cos 90, tan 0 and tan 90, all of those. Okay, you can even use the graphs to determine them. Okay, so sine 0 is 0. Sine 30 on the other hand, so I've drawn the specific triangles on purpose so that we can go through them. So sine 30, remember, it's opposite over hypotenuse. So easy. What is sine 30? A half. Okay, sine 30 is a half. Then we look at sine 45. Sine 45, we have two 45s in that triangle, so we can choose anyone. Opposite over hypotenuse, root 2 over 1. So it's simply root 2. Let's look at sine 60. That's opposite over hypotenuse. That is root 3 over 2. Okay. Then we talk about cos 30, adjacent over hypotenuse, root 3 over 2. Then we look at cos 45, so adjacent over hypotenuse, root 2 over 1. Let me just double check something, sorry. Yes, this is incorrect. Sorry, it's not root 2 and 1, it's 1 and 1 and root 2. Let's just fix that. So train smash. 1, 1 and root 2 here. You don't have to know these triangles. You just have to know the special angles. I just put in the triangles to maybe make you understand where it comes from or understand it better. Okay, so in this case, sine 45 is actually opposite over hypotenuse, 1 over root 2. And so too is cos 45, 1 over root 2. Let's look at cos 60, adjacent over hypotenuse, it is half. We talk about tangent 30, opposite over adjacent, 1 over root 3. Tangent 45, opposite over adjacent, 1 over 1, 1. Tangent 60, opposite over adjacent, root 3 over 1, just root 3. Okay, so you can see they're not like too bad to remember, in my personal humble opinion. Okay. Like it's better to memorize this so you have the unrationalized version. If you're going to put in your calculator, it's going to rationalize the denominator. It's going to give you slightly different. For example, here you're going to get root 2 over 2. And same with here. In here, you're going to get root 3 over 3, I think. And then if they might mark you wrong depending on your marker, because they say without a calculator, and if you're going to get the rationalized version, then obviously it meant to use your calculator. But if you just use these, it means you know your special angles, and yeah. Okay, these examples, we don't have to bother, it's corrected examples, but our main understanding of special angles is done. Let's talk about co-functions as well quickly before we end. Not end, but before we continue with reduction. If a plus b is equal to 90, then sine a plus cos b are known as co-functions. Sine a is equal to sine 90 minus b, which is cos b. That's a reduction. That's fine. But basically, you need to know if a plus b is equal to 90, then sine a is equal to cos b. Is that right? I think that's right. And then sine b is of course equal to sine cos A, sorry. Let's do an example. An example actually we can take from our special angles, right? We had cos 30. Now cos 30 is actually equal to a half. If you look at sine 60, sorry, just the other way around. Cos 30 is root, I'll just change it the other way around, okay. Either way, let's look at this, right? Sine 30 and cos 60. Sine 30 and cos 60, they are equal, okay? They are the complement of one another when they basically add up, because you see 30 and 60 add up to 90. So let's just change it. This is root 3 over 2. And you'll see that cos 60 is also root 3 over 2. Co-functions. Okay, cos 60, cos 30, sine 60. Even if you have to have anything. Okay, what would this be equal to? What would its co-function be? Cos 50. We know for a fact that sine 40 is going to be equal to cos 50. If A and B add up to 90, then their co-functions are equal to one another. The sine of A is equal to the cos of B, and the cos of A is equal to the sine of B. Okay, let's talk about reduction. Let's get my notes. Okay, we're going to start off with a simple one. Okay, so let's explain reduction. Okay, reduction is when we have a reduction angle. Now, our reduction angle in this case is 180 minus this entire thing. Okay, this helps us to determine which quadrant are we in. It helps us to determine the quadrant that we are in. Okay, now your cast diagram, you should know it at the back of your hand. Okay, so what I used to do, you feel free to just throw a little cast everywhere. So C-A-S-T. Yeah, just to remember it. Now you don't have to sit and think and use your brain. If you just throw it, it's there, you can refer to it. Now, one thing we need to notice, and we didn't go through here actually, was the reduction angles. So we start off here, okay, and here is 0. Okay, we'll come back to 360. But here is 0, okay? Here is 90. Here is 180. Here is 270. Now, above 0, we can say 0 plus. Alternatively, we can go from 90 and we can actually say 90 minus, anything below 90. Above 90, we can say 90 plus. But below 180, we can say 180 minus. After 180, we say 180 plus. Before 270, we say 270 minus. After 270, we say 270 plus. And then 360. For the fourth quadrant, we can say 360 minus. For the first quadrant, we can say 360 plus as well. Okay, so these are our reduction angles in which quadrants they belong. So for example, 270 my quadrant, 90 plus second quadrant, right? And so on and so forth. So when we talk about reduction, we want to determine which quadrant are we in to help us to determine whether our final answer is going to be negative or it's going to be positive. So someone tell me 180 minus is in which quadrant exactly? 180 minus. Correct. All right, you guys are correct. It's in the second quadrant. How do we know? Because again, this annotation here, 180 is there on the Cartesian plane, and everything below 180 minus would fall in the second quadrant. We don't talk about the first because that would surpass 90. Okay, so we say 180 minus. Okay, and therefore it belongs in the second quadrant. Now tell me, in the second quadrant, which I can use my little cast diagram here, even if I'd like, in the second quadrant, we're dealing with sign. Is sign positive or negative? Correct, 100%, right? Sign is positive. So how do we know that? Because we should memorize in the second quadrant, only sign is positive, everything else is negative. So actually our final answer is going to be a positive sign. Okay, our reduction angle falls away and we left behind with whatever angle remains behind without the reduction angle, which in this case is theta. So it's sine theta. So just give me like 1 minute. I'll be back shortly. Hello, I'm back. Okay. Okay, so I hope that makes sense. Right? If it doesn't, don't worry, we'll be doing 500 examples. Let's do number 2 out of 500. And then we can get into some exceptions, right? Let us do cosine 180 plus q. So let's take it step by step. Tell me which quadrant is 180 plus. Okay, you don't know. Again, like I said, I encourage you to each page, wherever you need to, just have a little cast diagram there. If it's not in your brain, or if it takes too long to render in your brain, it used to take me too long to render in my brain when I was in school. I should just throw a little cast diagram and then I can look at it and I can see. Okay, so 180 plus is certainly in the third quadrant. Okay, so for those of you who maybe are confused, you need to refer to this diagram. Okay, where you can see that more than 180 is 180 plus, which falls in the third quadrant. So third quadrant has two options, essentially. It's 180 plus or 270 minus. Okay, let's move on. Okay, so it's in the third quadrant. Okay, now we have to see is cos positive or negative in the third quadrant? Negative, negative. Correct, right? 100%. Cos is negative because only tangent is positive in the third quadrant. So my final answer is actually going to be negative cos. Okay, my reduction angle falls away. Whatever angle remains behind is what's going to be my angle. So negative cos q. Okay, so I think we're done with the basic examples. Let's talk about our exceptions. What are our exceptions? Let's get rid of this. Let's get rid of that. Our exceptions deal with 90 and 270. So the 90 and 270 exceptions. All trig cofunctions have exceptions. Sine, cos, and tangent. So for sine and cos, okay, how do we write this? For sine and cos, okay, if we reduce with if we reduce sine or cos with 90 or 270, then, okay, we need to change, sine will change to cos or vice versa, meaning cos needs to change to sine. Okay, that's for sine and cos. For tangent, we'll do examples. For tangent, we don't use 90 or 270. Okay, so for sine and cos, all right, when we use 90 or 270, if we're reducing with 90 or 270, then sine will change to cos and cos will change to sine. Reduction angle always fall away. Yes, when you're reducing, okay, you're reducing it, so the reduction angle falls away. When you're doing reduction, the reduction angle falls away. Okay, so sine and cos, if we're reducing sine or cos with 90 or 270, then sine will change to cos or cos will change to sine. I know these are rules and we haven't done them practically yet, but they'll make sense in a bit. With tangent, do not use 90 or 270. If you try to put 90 or 270 in your calculator, you'll see it's undefined. Okay, that's why we don't use them. Okay, it's also the asymptotes on the graph. Okay, so it makes sense as to why we don't use them. Okay, so let's do some examples and see what we mean by all of this, right? So we're going to do a first few examples with sine and cos. Okay, so let's do sine. Yeah, I guess 90 plus theta. For my little cast diagram. Firstly, tell me 90 plus is in which quadrant? Okay, correct. Second. Okay, so the first thing to note is that we need to note our first trig ratio. So sine. Okay, you'll see why I say first trig ratio in a second. Okay, so our first trig ratio, sine. Okay, is sine positive or negative in the second quadrant? Positive. So that is going to determine my numerical sign, like, because there's, there's sine, then there's sine. Okay, one is a trigonometric cofunction, one is a numerical operation. Okay, so positive. Now, I will not write sine. Why? Because when I deal with sine and 90 as the reduction angle, I change from sine, my answer will be cos. And then whatever angle I'm left off with, theta. So do you see how, what determined my numerical sign? The first trig ratio, which in this case was sine. In my reduction angle, sorry, using my reduction angle, I decided which quadrant am I in? Second quadrant. Is my first trig ratio positive or negative? It is positive, therefore I put down positive, and then I will put down change from sine to cos. If you don't do that, if you're going to use cos, you're going to get negative, because in the second quadrant, cos is negative. But we don't care, we get our sine from the first trig ratio. Let's do another example. Let's do cos 270 minus, let's do 270 plus. Okay, firstly, I want an attempt to the final answer. Thank you. I want an attempt to the final answer. I want an attempt to the final answer. Just give me the answer for this. This is the final answer. I just want everyone's attempt to the final answer. Like completely, not just sine. Like tell me the final answer is positive tan theta. Yeah, Q is fine. You can use Q, because I don't know how you're going to type in theta. You can use Q. Positive sine q, negative, positive cos q, negative sine q, positive sine q. Positive sine q. I'll wait for one more answer and then we'll do it. And don't delete your answers, eh? Can I remove the ability for you guys to delete messages? Because people send the incorrect answer and then I want to correct them, but then poof goes the message. Okay, negative sine q. Okay, so let us discuss it. Okay, then we have a positive sine q. So firstly, dissect it. Okay, take it step by step. 270 plus. Generally what we work with first. 270 plus. Okay, actually in this specific one, you should always notice, right? The first thing you should notice is that you're dealing with cos and 270. Remember, there's exceptions. So basically, whenever you see 90 and 270, you have to think to yourself, you're like, whoa, okay, there's exceptions with 90 and 270 with all trig ratios, with sine and cos and tangent. Okay, so sine and cos, I need to change from sine to cos or cos to sine, and then tangent, right? I can't use 90 and 270. So for the person that had cos, do you see that's already incorrect? Because you're supposed to have sine, definitely. Like your final answer is going to be sine because you're dealing with 90 and 270, right? First correction. Hope that makes sense. Then you ask yourself, okay, again, we're not that smart, so we do a little cute cast diagram and we move on with life. Okay, and cast diagram, you ask yourself, where is 270 plus in? That's in the fourth quadrant. Why? Why do you have to do that? That's in the fourth quadrant. Okay, then you ask yourself, then you ask yourself, so it's supposed to be sine, okay, it's fine, doesn't matter. Then you ask yourself, the first trigonometric ratio, because I know it's going to change, is cos positive or negative in the fourth quadrant? Tell me now, is cos positive or negative in the fourth quadrant? Not positive. Oh, no, sorry, not negative. Cos is positive in the fourth quadrant. Only cos is positive, so cos is positive. So positive is going to be my numerical sign. Okay, but I'm not going to say cos. Why? Because it is dealing with cos and 270. So we can even underline that. And therefore, it's going to change to sine. And whatever angle I'm left with after my reduction angle falls away, sine theta. Okay, let's do another one. Let us do sine 270 plus theta. Give me your final answers. Okay, I see a negative sine cube. Remember, it's dealing with sine and 270, so it needs to change to cos. Then we have negative cos q, positive cos q, negative cos q, another negative cos q, cos q. Okay, let's go through it, right? Okay, so I just want to talk about something. Maybe, I don't know, this was a thing when I was in school, but like teachers always told you, like told me, and I feel like many students that I've taught over the past few years, they have the notion that you can't use 270 or you shouldn't use 270 or 270 is some scary number that you should not use for some reason. Okay, I don't know why there's that notion, whereas it just works exactly like 90. 270 works exactly like 90, where you change it from sine to cos and cos to sine. Okay, so yeah, cool. If your teachers told you that, then just ignore them. So we dissect it. The first thing we do notice is, yes, what? Sine and 270 Therefore, it's going to change to cos, number one. Number two, we consider our quadrant that we're in. 270 plus. 270 plus is in the fourth quadrant. Okay. I ask myself, my first trig ratio, is it positive or negative in the fourth quadrant? Now answer the question. Is sine positive or negative in the first quadrant? In the fourth quadrant, sorry. Negative, exactly. Okay, so then my numerical sign is going to be negative. My trigonometric ratio is going to be cos. Why cos? Because it's sine in 270. Thereafter, I take this guy and it becomes cos theta. Okay, I hope it's making sense so far. Okay, so that's the 90 to 70 rule. Obviously, there's nothing to do for 10 because we just can't use 90 and 270. All right, let's do the next exception. Let's do negative angles. Is there anything else? Okay, let's just do one example with tangent, just so that it doesn't feel left out. Okay, so I'm reducing the angle of 60. Okay, so yes, this could be less than as tan 300, but I'm just reducing it. So you can treat this like theta as well. Okay, so actually, we also don't know the value of tangent 300, but what we can do is say 360 minus 60, because we can get the value of tan 60 and then get the answer. So reduce this, please give me final answers, just in terms of trig. I don't want you to simplify it in your calculator. Like tangent 60 or negative tangent 60, that type of thing. Give me the final answer for this, please. It works. Theta is same like 60. Okay, excellent, right? So we break it down. We ask ourselves, what quadrant are we in? 360 minus is in the fourth quadrant. Only cos is positive. Tangent is negative. So I'm going to have negative tangent 60. Correct? I think we revised special angles just now. So tangent 60, we said was root, I think we said it was 1. No. Tangent is 2 over root 3 or something. 1, yeah, it was, no, it was root 3, it was root 3. So this is negative root 3, if you want to simplify to the final value. Okay, let's move on to let's do negative angles. Okay. Okay, so we're just going to continue off a little bit. For those who have to leave, please leave. We actually have a bit of an issue. Load shedding is going to kick in. So if we're not done by like 12, we're going to try and finish by 12. I'll have to leave early. No problem. You can just, I'm literally just going to do negative angles, maybe do one example. So you can always watch it later using the videos. Okay. So discussing negative angles. It's basically, you need to memorize these, you just need to learn them. If you have sine negative x, for example, okay, this simply simplifies to negative sine x. Okay, then if you have tangent negative x, this simply simplifies to negative tangent x. However, if you have cos negative x, cos is very hungry. And what it does is it actually swallows that x. And it just simplifies to cos x. That's it. Okay, so these are important. Just know the exception that if you have a negative angle for cos, it doesn't become ever negative cos x. Right, the negative angle doesn't make cos negative. Why is that so weird? I'll fix it later. Okay. However, for sine negative x, that becomes negative sine x. For tangent negative x, we can simplify that to negative tangent x. For cos, on the other hand, cos negative x is just equal to cos x. Okay. So, Rosen, hello, move, please. Okay. So, now let's do an example. Okay, so that's easy in itself, like if you just have negative x, for example, right? But now let's just say we had an example like this. Just say we have sine x minus 180. What's weird about this? Can we reduce this? Like, what is our reduction angle? Which quadrant are we in? What is strange about this? One. I'll tell you what's different about this. The angle is negative, exactly. You can't have the reduction angle as a negative, 100%. Thank you very much, right? So whenever we deal with reduction angles, we have 90 plus, 90 minus, 180 plus, 180 minus, so on. So when you notice in these reduction angles, the reduction angles themselves are always positive. So whether they have a negative or positive that comes after it, the reduction angles themselves are always positive. 90 minus, 180 minus, 360 minus, they're all just positive values. However, in this case, we have a negative reduction angle. Now that is an issue. You cannot have a negative reduction angle. So you need to find a way to make this positive. Okay, so now one way to make it positive is to take out a negative bracket. So to take out -1 is a common factor. Okay, and it doesn't change the value. I'll show you how. You're not going to do this long method. You're just going to shortcut it, but let's just do it for now. So I'm going to take out a negative bracket, and I actually have negative x plus 180. Okay, so I hope you guys see how that makes sense. Taking out a negative bracket is a common factor because when I multiply this back in, I actually end up with what I had. So I'm not changing the value. It becomes negative times negative x is positive x. Negative times positive is 180. So I'm not changing the value if I distribute it again. Okay, so now this simplifies to, if I rearrange it with the positive first, or my reduction angle first, it simplifies to, let's actually just use round brackets. Why do we need to just bigger round brackets? Okay, negative 180 minus x. I just rearranged the two. Okay, now this makes more sense, right? To reduce this 180 minus x, that looks a lot more better. Okay, where we have a reduction angle that's positive. That's like what we used to see. However, this negative, okay, remember we just learned, right? We just learned what? We just learned that sine, as we can use square brackets. We just learned that sine negative x, okay, is equal to negative sine x. So what we can do, right, is 180 minus x, we can treat this like an angle. Like imagine this was y. It would be like negative sine y. Imagine this whole thing could just be expressed as y. It would be like sine negative y. Okay, so to treat this just like one thing. Okay, and in that case, you can take the negative out. So you take the negative out, negative sine 180 minus x. So this like is your angle, basically. Let's write that. This is your angle. The entire thing, like your angle is not just x, or angle is not just 90, or it's not just 60. Your angle is 180 minus x. That entire thing you treat as one angle. And then you can take your negative out. So it becomes negative sine 180 minus x. Now, all of this is long stories. You don't have to write a single thing because we are smart and we are all the way in grade 12 minus 1. We can skip directly to the end, right? So let's do another example. Let's just make it a bit tricky. Okay, let's not make it tricky. Sine cos is where? Let's just say cos 360 minus, no, let's just say cos x minus 360. Okay, so the issue here is that we have a negative. Sorry, let me just make this the next class to one and that we are running a bit late. 1 second. Cool. Okay. So in this case, we noticed we have a negative reduction angle. We're like, okay, that's an issue. We need to change it. How do we make it positive? By basically taking out the negative bracket. And I showed you how to do that here, right? That's how we take out the negative bracket. But we're not going to go through all of that stories, and you're not going to get marks for any of that. You are going to, wait, and that doesn't exist. Let's just make it tangent. That's fine. So now, okay, you are going to, this is important, we'll do these two examples and we'll end there. And there's more examples we still need to do, but we'll get there eventually. Because like once you know all the rules, right, technically like we don't even have to practice any questions, because once you know all the rules, you'll be able to answer any reduction question. Okay, obviously we all practice, but I'm just saying that's the most important thing is to get all the rules done. Okay, so in this specific case, right, I need to take the negative bracket. I know this whole process because you just saw it here. Take the negative bracket and take the negative out. But again, like I said, you're not going to get marks for it. So what you need to do is you need to immediately realize, okay, this is a negative reduction angle. I can swap these two around and make it negative 10. Negative 10, this is equal. Negative 10 is equal to 360 minus x. Sorry, negative 10, 360 minus x. I hope that makes sense. So you just flip the insides and make it negative. Okay, so now please remember this negative. Let's clarify the definition of reduction. Reduction is when we decide what quadrant we are in, and then we reduce the angle accordingly, and that can give us a sign depending on whether something's negative or positive in a certain quadrant. This negative didn't come from reduction. This negative came from the fact that we had a negative reduction angle and we took a negative bracket and then the negative came outside. That's why we got this negative. It's from the fact that we took the negative bracket. So now we have this extra negative here. We still need to reduce it, and that will give us another sign, either positive or negative. So now we can actually reduce it, right? I don't know if we reduced the previous one. No, we didn't. Okay, we'll go back to doing that. So we have negative tangent 360 minus x. Now 360 minus x, what quadrant is that in? 360 minus is in the fourth quadrant. Is tangent positive or negative? Don't have to answer this, I'll answer it. Is tangent negative or positive in the fourth quadrant? It's negative. So this gives us another negative. So it's like a negative times a negative tangent x, which thereafter simplifies to positive tangent x. Okay, let's do this one also. Let's complete this. So we still need to reduce this. We just made it a negative angle. So let's reduce it. Right. 180 minus is in which quadrant? It's in the second quadrant. Sine is positive in the second quadrant. So it stays, remember, it's like negative times a positive. You don't have to write the positive, but the negative still remains behind. Just to note that that extra negative can come from, not reduction, it comes from taking the negative bracket. Okay, and then when you take the negative bracket, you get a negative in sine and tan, then you can get another negative from reduction as well, or positive. Now, before we move on, let's do one cos example, because remember, cos swallows that negative. So how do we deal with that? So here we said cos. Let's make it annoying. Let's say x, no, we can't say minus 90. Minus x minus, yes, we can say that. X minus 270 degrees. Okay, I want quickly, if you guys still have brain cells remaining, I want a final answer for this quickly. Quickly. Like final answer, like at the end. So you can take like a minute to do it if you want. I just want the final answer, the end answer. Like I want you to reduce it as well. Okay, cool. We have 2 answers. Okay, let's go ahead and do it, right? Sorry for those who aren't finished. So first thing, okay, I would like you to notice the first thing, like always just have it in your brain wired, cos in 270. That's like a red flag immediately, like, okay, whoa, whoa, whoa. Yes, the person in YouTube, cos in 270. What is that supposed to do for us? It's one of the exceptions where cos is going to change to sine. Okay. However, I cannot reduce yet because this is all mixed up. Why is it mixed up? Because I have a negative reduction angle. Okay, so I have to sort that out first, right? So it's like I take a negative bracket. Okay, it's like I take a negative bracket, like cos, I'm just going to do it this time, negative 270 minus x. All right, it's like I take a negative bracket. Why am I doing it the long way this time? Because why? This negative, it does not become negative cos 270. Does not become this. Why? Because cos swallows that negative. So even in the example like this just simply changes to cos 270 minus x. So that's the nice thing. It doesn't matter because cos swallows that same negative. So remember that negative angle goes outside. We learned it here, negative angles. But cos swallows that negative. So it doesn't matter. Even if we have a term here, like our angle has 2 terms, 270 and x. If we have that negative bracket, the negative goes out and it doesn't stay outside. Cos swallows it. So this is the same as cos 270 minus x. Now we can reduce. So firstly, again, I noticed 270. Let's use our colors. 270 and cos. Okay, so I'm like, oh, okay, it's going to change to sine. Secondly, I'm like, okay, what quadrant are we in? 270 minus. I draw up my little thingy-mabob. And then I'm like, oh, okay, 270 minus, that's in the third quadrant. Now, cos is negative. So I'm like, okay, like 500 rules in this one, because I need to determine the sign, the numerical sign, from the first trig ratio. Because remember, it's going to change to sine. Okay, I could have used 90 plus, but it's fine. Could have said x. No, but it doesn't matter then in that case, whatever. So remember, the first trig ratio is going to determine the numerical sign. Okay, so here 270 minus cos is negative, so I'm going to have a negative. So a lot of people, when it comes to taking out the negative bracket with cos, they shy or they get scared to put the negative in front. Please note that cos can become negative from reduction. The only negative that cos will swallow is when it's a negative angle itself. However, cos can get a negative from reduction. Okay, when you're reducing using these angles. Okay, so the negative is coming from the fact that cos is negative in which quadrant? The third quadrant. Okay, and then I'm changing to sine. Why? Because it's cos 270. Okay, so this can get a bit trickier. The more practice you have, the better. Okay, and then I'm pretty sure it's just x. Okay, I'm not sure if you guys can hear me. Just confirm the lights have gone. So please just confirm quickly that you guys can hear me. Then I'll finish up. We're pretty much done, but yeah. Okay, perfect. So I'll share my screen again and then we can just conclude. Okay, I can't really see chat again, but yeah, I think most of you did say negative sin x. But yeah, okay. Basically, that's what we have. Okay, I hope that makes sense. Is this correct? Is this final answer? Cos 270, cos changes to sine, negative, yeah. Okay, so again, just don't be shy to the fact that cos can get a negative. Okay, this one changed to sine, but cos can still get a negative from reduction, just that it swallows that negative if it's a negative angle. Okay, cool. I hope that makes sense. We will do maybe some more examples and like one big example next time when we continue. Okay, we'll continue with reduction, move on to Cartesian plane questions. In terms of questions, the hardest one generally, identities, and then eventually general solution. So it's a long, lot of stuff, big topic. I know we are slightly behind, but again, sorry, we started a bit late, and hopefully we will catch up to you guys by second term at this point. But yeah, okay, cool. So I will see you guys then next week, same time. Thank you guys so much for joining. I hope you guys have a good week at school. And yeah, jazakallah khair. Thank you guys. Assalamu alaikum and goodbye.